Hey everyone, it is time for another React lesson. What we're going to be looking at today is how to compose stateful logic in React. What we're doing here, right, is it's easy enough to share certain types of logic between components. We just put it in a function, we call it with arguments, we get the result, that's all good. But actually interacting with state inside of our React components is kind of trapped inside of the component is what we're able to do with it. So we have a couple solutions to this problem in React, and all are valid, all have benefits, and all have trade-offs, so we're going to be looking at a couple today. We're going to be doing higher order components, which allow us to create, before we render our React application, a component that contains that logic. We also have render props, which allow us to dynamically respond with a function. We have hooks, which is what the React team specifically created to help solve this problem of sharing stateful logic. And we also have context. Context is kind of a combination of some of our previous options. You can use context with hooks. You can also use it with render props. But it does assist in the way that we help manage sharing stateful logic, but also instances of that state between multiple components, and gives us some different tools in how we want to represent certain bits of our stateful logic. So we're going to go ahead and get started by implementing the logic that we want to share today, which is a toggle, right? Very simple, right? We just have a Boolean in state and a function that flips that. Chances are we're fine writing this hundreds of times, but I think it's a good simple example to show how we can share this without focusing too much on what we're sharing. So we're going to start by writing this with a class-based component and then a function component. I haven't written a class-based component in a while, so please excuse me if I make any silly mistakes here. I'm going to go ahead and put a Boolean variable is open into our state. I like naming my Booleans with a prefix like is or something to indicate that it is a Boolean and not a function, right? If this were open, that might imply that that is an action that we can undertake. So we've got that. I'm also going to add a type here. We're using TypeScript. And if you don't know TypeScript, then you can just actually ignore this part. Or all I'm doing here is I'm saying I have a React component. The props it receives are undefined. We're not going to be worrying about props here. And its state has a type of an object that contains a Boolean key is open. So we've got that. I'm also going to write a method here called toggle. And all this is going to do is it's going to flip that in state for us. So I'm going to call this dot set state. I'm going to get our previous state. And then I'm going to spread that into a new object and flip the value of is open. And I'm just going to do that by saying is open is equal to the opposite of our previous value of state. And there we go. There's that logic. And now what I can do is I can, render a button. And I can do things based on the state. So if this dot is open, this is going to say open. Otherwise, it's going to say closed. And then on click, we will call toggle. This dot toggle. This dot state dot is open. See, I am rusty with class-based components. Okay, so now we'll render this toggle class. Failed to compile. I think this might need to be, yep, there we go. And that should do it once TypeScript recompiles. There we go. So now we have a little toggle button. We can toggle it open and closed. We can use a checkbox or a radio button for this as well. We could also do some CSS for a toggle, which we might do if we have time at the end. But for now, right, this is what we care about, is this stateful logic of the is open value in our state and the toggle function. Right, how we want to render this, we can render this a million different ways, right? This logic can be used in an untold number of components, whether it is, a checkbox or a radio button or a tab or a drop-down menu, right? This state is largely independent of the view layer that we want to attach it to. But, right, these are stuck inside this component. this state and this toggle function, they are stuck here. Now some of you might be thinking, well, it's a class, right? If I want these parts of my class, well then I can inherit from it. I can use extends and do something like this. You know, class checkbox, extends toggle class. And you should never, ever, never, 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 ever, ever do that. There are much smarter people than me on the internet who have written about why we shouldn't use inheritance with React specifically, and kind of in general. I don't think inheritance is a good solution to this problem, so we're not going to do it. Instead, we are going to also write this toggle component in a functional component. So I'm going to need useState. We'll just write this again real quickly. Const is open, set is open. That's going to be useState of true. We'll just default these to true. And then we'll write our toggle function, which is going to look pretty much the same, right? This part doesn't actually change that much from class to function-based components. So instead, we're going to get current value of isOpen, and we're going to toggle it. I've used the callback versions of both of our setter functions, right? Set isOpen and set state. I didn't really need to do this, but when you have state that depends on previous state, it's pretty much a good idea to do this always, because this way you don't get caught by some asynchronous bug, right? If we called an old version of toggle inside of, you know, some asynchronous thing, then it might reference an old value of isOpen, and that can cause issues. And kind of the opposite is true in class-based components, where state may have mutated out from under us, so we don't actually know what the value of this.state.isOpen is. So I like to use those callback versions. And now, copy our rendering logic here, right? This will be toggle, and then this is just isOpen. Right, so our stateful logic is very similar, right? HOCs versus class-based components, but we'll note that the rendering logic is identical. And that's really what we're getting at here, is the fact that I don't really care how this state is implemented. This part here, right, our JSX, how we're representing these two buttons on our screen, is the same. And the interface is the same. You can ignore this, right? You can ignore this .state. It doesn't really matter. The idea is that our render function here and our return value here are identical. They expect a Boolean called isOpen, and they expect a function called toggle, and they do not care how that's implemented, right? It's referentially transparent. Those could be, you know, implemented in any way. We could be using Redux, we could be using hooks, we could be using class components, we could be using anything. But this button that we're actually rendering doesn't care. And so the solution that I want is a way to share the implementation of our state in a way that we can reuse it while rendering many different types of things onto our screen. And so we're going to take a look at our first method for doing this, and that is higher order components. The idea behind a higher order component is that we can create a function, and our naming convention is to call it with, lowercase with, and then something else. So in this case, with toggle, and we'll give with toggle a component. And what it will do is it will return a new component for us that wraps our stateless toggle component, our view layer, with another component that contains the stateful logic and passes it down as props. And this is a very inventive solution, very, very confusing to new developers because it does things that are not immediately apparent. Right? With toggle, this thing, we're getting a new component, right? We're just used to writing JSX, and we'll look at other solutions that fit a bit better in that paradigm. So what we would do is we would say, write a function called with toggle. And now you're going to listen to me get mad about the name higher order components. So we all know what a higher order function is, right? If I have an array and I call map on it, map expects a callback function, that does things to the elements of my array, right? So map is a higher order function because it is a function that takes another function as an argument. That's all this means. With toggle, it's not a higher order component. It is not a component that takes another component as an argument. In fact, what does do that is every component that accepts children. So I don't know exactly why they picked this name, higher order component. It doesn't really fit in my mind with what that term would mean, but that is what the community has decided is the standard. So that's what these are called. And the idea here is that whether this returns a class component or a function component, it doesn't matter. I'm going to use a function component just because it allows us to be a little bit more succinct, is that it expects as an argument a React component. I'm going to call this component that accepts the props is open, which is a Boolean, and toggle, which is a function that does not return anything. I'm going to split these out into a type here and call this toggle props. And there we go, toggle props. So we can just say toggle props. So it's going to contain our stateful logic, and then what it's going to do is it's going to return our component with the props being applied to it. So it is going to receive toggle as the toggle prop and isOpen as the isOpen prop. And we'll close that up here. Oh, what is the type for this? I'm doing this one with no practice here, so you have to bear with me as I make a few mistakes. Because I could probably do this, right? Let's see if this works. React.createElement component toggle isOpen. Nope, I'm using the wrong type here. Is it just component type? Is that what I'm missing? Yep, that was it. Okay. TypeScript things. So the type of this is component type and not component. And this is one of many reasons why not all developers love TypeScript, is that there's lots of weird gotchas and just, I don't know why that didn't work. It has to be a different thing. What's the reason? It's not that good. But the type that we expect here is React.componentType, and then we're telling it what kind of props that component should expect. Which, right, if you're following along at home with just JavaScript, hey, just don't put that there. Whew, now we have JavaScript, no big deal. So if you're struggling with the TypeScript part, just ignore it. All right. So now what I can do is I can say something like const dropdown is equal to with toggle, and then I can define some React component, which I'm just going to do inline here. It's going to take isOpen, it's going to take toggle, these are of type toggle props, and then it would do something like, oh, it's going to be mad because this is not a React component. Drop down view layer is what we're going to call this. And this is of type React.function component. Toggle props, put those there. And then what this does is not really important. Right here, with toggle, drop down, view layer. And these are very bad component names, but I'm trying to be explicit here so that we don't end up doing things that we do not expect. And what is TypeScript complaining about? Oh, Okay, so this is one of the things that is weird about higher order components, is that with toggle is not a component. I've written this as if it were a component, and you could render with toggle, and it would do these things, right? That is not what with toggle does. What with toggle does is it returns a React component. So what this should actually be is returning a function that does all of this stuff, right? There we go. So this is kind of where we get the term higher order component from, even though it's not, that in my mind, totally mathematically accurate, is that we're creating a component that wraps our view layer, that wraps whatever we want to use the stateful toggle logic to turn into stuff that our user sees. So now we have our dropdown component, which is the combination of the dropdown view layer, right? Where we can say, you know, if is open, then what we're going to do is say some div. This is a dropdown. And then I'll just have it be on click. This will toggle. Web mode, and this needs to be wrapped in a fragment. And now we can render our drop-down component. Right, and now we can toggle our drop-down by clicking on this. And this is essentially the same thing as either of these toggles, right? But what we've managed to do is we've managed to separate the logic it takes to drive a drop-down, to drive a toggle, into something else besides the view layer, which is this dumb component, which is a term that I really love and haven't been using enough lately. The idea that drop-down view layer is dumb. It takes these two props, a Boolean and a function. It does not care how they're implemented. It does not care how they work. It does not care where they come from. Right? I could re-implement isOpen and toggle inside of app and pass them just fine to drop-down view layer. It does not care where they come from. But now I'm able to create this reusable factory with toggle, where I can give it any component that I want that accepts those props, and I can reuse this same set of hooks and custom functions or class-based stateful logic or whatever. It doesn't matter. I get to write the state once and then use it in my view layer wherever and however I see fit. Instead of this being on click, this could be, you know, on mouse enter or on mouse leave or something. Right? And so now I can mouse in and out. And we don't have to worry about changing any of our actual stateful logic. That just stays in the dump component. So, do we have any questions here? All right. Cool. So that is an HOC. I don't want to say anything bad about HOCs because I don't want to necessarily color your opinions on solutions to problems with fashion, but HOCs are starting to go out of style now that we have hooks, which we'll get to later. HOCs were kind of the gold standard solution in the class-based era of React because it allowed you to efficiently handle this kind of composition without inheritance, which we don't want to do and cannot do with function components, while avoiding some of the drawbacks of render props, which is what we're going to see next. HOCs are definitely still valid. There's absolutely places that it still makes a large amount of sense to use. There's nothing wrong with them, or we're starting to see them less and less as a solution to this problem, as the first solution that we might reach to. Because as you can see, this is a little bit complicated, right? This function itself, especially if I write this in the abbreviated style, like this. Oh, should that still be there? function. Right? If I were to write this like this, this becomes functionally identical. It's a function that returns another function that is a component. However, this is very impenetrable for people who are not familiar with some of the more interesting aspects of the JavaScript arrow function syntax. So HOCs are kind of hard. They're kind of hard to wrap your head around, especially for beginners. And they're a bit odd in the sense that we have to do this down here at the bottom. I have to, before my component is rendered, I have to say, I'm going to create this drop-down component, which is a combination of these two things. I cannot do it inside of my JSX. And as React developers, we want to pack as much stuff into that return block, that JSX blob at the end of our component as possible, right? That's what being a React dev is all about. So now let's move these down to the bottom of this file, and let's take a look at render props. So the idea behind render props is, in this case, it's a render child, but I want to dynamically, in my JSX, I want to give the component that holds the stateful logic a function that will return JSX, right? In essence, I want to create an on-the-fly component that will receive the stateful stuff and then will render something onto the page. And that's why we call this a render prop. So let's take a look at how that would work. So what we would do is we're going to create a component. We'll call this toggle render. Any preference on whether we do this with a class-based component or a function component?
Function.
Function? Okay, cool. So what this is going to do is this is going to be a function component, and it is going to accept a single prop. We'll call it render. And the type this is it's going to be a function that is going to return JSX. And this is really, right, the trick that keeps TypeScript developers sane, which is I'm an Emacs, right? But if you're in VS Code, which I'm assuming you are because everyone is, first class TypeScript support as well. If you hover over something, it will tell you its type. So when we write a function component, its return type is JSX.element. Right, that is the return type, and we can see that here as well. If we go into the definition of React.function component and follow this chain all the way back, we'll see that it returns JSX.element. Where does the JSX namespace come from? I don't know. That's just what TypeScript tells me, and sometimes you just gotta roll with it. So I want a function that returns a JSX element, and it is going to accept our toggle props. All right, so we're taking a prop called render. Cannot use namespace as a value. I think I have to wrap this in a set of parentheses. Oh no, it's because I'm doing bad TypeScript things. I have to write this twice. There's our type, and then here's our props. There we go. So props is an object that has a key called render that I'm destructuring, and then colon, here is the type of those props. It is an object, it contains a key called render, and its value is a function that takes toggle props and returns a JSX element. Now it's important to note, I keep calling this a function, and some of you might think, oh, well, this is the exact function signature of a React component, right? And it turns out it's not, because this is not going to have a constant identity. This is going to change on every render, and we're going to do an interesting thing to it that we would never normally do to an actual React component, class or function or otherwise. So what we're going to do is we would take our logic, right, that ideally we're only writing once, and then we would call our render prop with isOpen and toggle, which is the arguments that it expects. And that's what a render prop is, right? Now, normally, you would expect us to do something like this. Return render, isOpen is equal to isOpen, and, toggle is equal to toggle, right? That is not what we're doing here. Render is not a component. Render is very specifically a function that returns JSX. That is different than a function component because of what it looks like when we use this. So when I say something like toggle render, and I give it a render prop, which is going to take isOpen and toggle, and it's going to return some JSX. Right, we'll try to get this to be a little bit more readable. Let's just return a div that says I'm rendered as is open, otherwise closed. And I missed a closing slash here. There we go. We can't do this. So now if we come over here, right, we have the result of this toggle render. And the reason that we can't consider this, the argument that I'm giving it here, a React component, is that if I were to re-render app, if some state change or something else caused us to re-render app, we would create a new function that's being passed here, right? When we rerun a function component, we just recreate the whole thing top to bottom, run the function, get the return output, React does the whole DOM diffing thing, and we're good to go. Except the argument that I'm giving to toggle render is going to be a new function each time. So it's not going to have a constant identity, which is going to prevent React from being able to do its React magic to avoid re-renders or putting hooks inside of it, right? I cannot actually use a hook inside of this because it's going to be a different function next time, and React isn't going to know to carry that hook value forward because hooks use some weird dark magic. So we can't do that. However, not all is lost here. This isn't necessarily a drawback because I can do things like say const variable is equal to some value, and now I can use the value of this variable in this function. And if this value of this variable would change, well then this function, given as a render prop, will also change. And it will have the new value of variable in its closure. And so we're able to just change how this thing renders on the fly. We don't have to worry about adding a new prop to the component that's coming in here. How do we even pass that prop to this component when it's already, accepting these? So this solves that problem of being able to add more props, right? Essentially more data to what we are rendering. Whereas with our higher order component, right, when I made dropdown, right, dropdown specifically doesn't take any more props. I can't give it more info. And there are ways of getting around that with higher order components. Certainly that's not a permanent deficiency of that pattern, otherwise we wouldn't really use it that much. And we can do some interesting TypeScript things if we want on how to make sure that that is type safe. But that is annoying, right? And it makes our HOC, it makes with toggle all the more complicated to have to manage passing props from this layer down into this layer. So render props make that very easy to get additional data into the thing that we want to render. The drawback is that there's a performance cost to this. We have to call our render prop. We have to call it as a function on every render. We can't memoize this. We can't use hooks directly inside of it. We can render a component that uses hooks inside of this. That's actually fine, but not directly inside of this callback function. So We tend to avoid render props when they start causing performance issues, when we end up calling this thing a whole bunch of times and we want to memoize it or something. But other than that, it's a very quick, efficient way of getting that extra data into something that you need to compose with your existing logic. Any questions with that? All right. Neat. So we'll notice that there's a slight difference in the syntax that I'm using here versus in the README. In this case, I use a prop literally called render, hence the name render props. And here I did this with the children of this component. And these are the exact same pattern, right? All I've done is just honestly make it slightly more legible instead of having this like weird big prop. Now it's just the children. And these are the same thing. We still call it render props because that's what the pattern is called, especially because children is actually just another prop, right? Children is just JSX conveniently abstracting away any children we give to the component in this JSX hierarchy. Just becomes a prop called children. So I can just change the name, right, of this from being render to children and all the places that I use it. And nothing has happened. Nothing has broken. And so I can just take this and instead of giving it as a prop, I can give it as the only child of toggle render. Now, if we were being responsible, we would do some TypeScript things to make sure that everything is all good, and maybe this is optional, and maybe it can accept different types of children, but we don't have to do that here. And TypeScript will actually prevent us from doing something like this. Right? Div is not of type the function type signature that we wrote. So now we have our render props as a render child, which can be a slightly more ergonomic solution in some cases, especially if you want to prevent someone from accidentally doing both. So that is render props. Render hops generally more flexible than HOCs, potentially less performant. That's the big trade-off here. Okay, so then we'll talk about hooks. Right, so these solutions and others are kind of what prompted the React developers to act upon this issue. Is because this is an incredibly common problem. It's not even a problem, it's just a requirement of any software that you would want to write with React, is that you would write a reusable set of logic, right? Like our toggle. This toggle logic can be used to power an innumerable amount of components that just switch things on and off depending on a Boolean, right? We use that all the time. That is a constant of React development, and same with other things that we want to do. But both render props and higher order components have these kinds of weird, hard edge cases. So the idea behind hooks is a way to, one, include stateful logic in function components, which helps eliminate some of the boilerplate and burden of supporting class-based components. But two, give us an incredibly easy and accessible escape hatch for sharing stateful logic. And so what we're going to do is I'm going to come down here and I'm going to grab our toggle function. Right? Actually, let's actually just cut it. We'll cut it and put it right up top. Right, so this is our toggle function. And what we want to do is we want to take this, right? We want to take this logic, and I want to use it in another component, which, what's another thing? Well, we'll make the checkbox component this time. the checkbox component is going to return and input. I have to go to MDN for this. Okay, yeah. It's input of type checkbox. I always forget, sometimes like it's not an input. Is it a radio button? There's one of these input things that I always expect to be an input, but it isn't. And then we'll set the value of checked. This is one of the things that always gets me. This does not have a value, right? We don't set a value prop on a checkbox input. Its prop is called checked. So I want this check to be isOpen, and then I want onClick to call toggle. Right, the problem is neither of those are defined. We don't have isOpen. We don't have toggle. And, right, simply enough, I could copy and paste these, right? And now this will work. My checkbox will be perfect. However, we don't want to copy and paste that code, right? We don't want to repeat ourselves. But I don't want to immediately have to jump into the overhead that is writing an HOC or writing this render props wrapper component. Instead, what I want to do is I want to create a custom hook like useState. And this is exactly as easy as copying and pasting this code was, is because the only thing that a hook is a function that starts with the word use in lowercase, and it has hooks inside of it. There you go. You made a custom hook. This is a custom hook. We're going to return isOpen, and we're going to return toggle. And to make TypeScript happy, I have to say this is as const, so TypeScript will know to treat this as a pair, an array with exactly two things in it that are the types that they are, instead of being an array of arbitrary length that can contain booleans or functions. And now I can say isOpen and toggle is equal to our custom hook use toggle. And that's it. That's all it takes to make a custom hook. Is you just literally take the logic that you have using hooks and you put it into a function that starts with the word use in lowercase. Boom, end of story. That's custom hooks. Custom hooks can be spooky to a lot of people at first, especially when you see them used in like big, meaningful ways, right? All I've actually done is actually make a worse useState hook here, right? I don't even have the option of forcing a toggle to be open or closed, and that's bad. This probably should not be a custom hook, but that betrays the essence of this example, which is that you just take the hook stuff you did, and then you put it into another function. And it's so wonderfully simple. And despite some other challenges that hooks introduce, I think that the ability to handle this sharing of stateful logic between things so easily is what makes React so powerful with the addition of this. I really enjoy this over some of our previous options, because there's no boilerplate except adding this return. Right? We don't have to worry about the complexities of the previous things. We've just got it. Do we have any questions with that?
Any gotchas when creating custom hooks?
Yes. Luckily for us, the React linter is great, and will help prevent you from making a lot of mistakes with custom hooks. Like, for example, this is now capital U use toggle. And technically this would work. But, oh, is the linter not firing? Maybe I just have to use another word besides use. I'll just put a placeholder here. And see if it complains. Yep. So the React linter, and in this case the TypeScript compiler, is just not going to let us proceed because it does not follow the naming conventions of lowercase u's. And this is going to seem stupid, right? That why would this even matter in the first place? But what makes this pretty important to me is that it enforces kind of a uniformity. I know what I'm getting into when I see someone calling a hook because it always starts with lowercase u's, as opposed to higher order functions, right, where our with syntax and whether or not things are curried or any of these other choices here, those are kind of taken away from us. We can do less. And so that's an important thing to me in terms of making it obvious what our custom hook is and what it is doing. And we have to add the read-only prop to this as well, which the linter is kind enough to inform us of as well. I mean, other gotchas include just, stuff depending on what your custom hook is doing. You have to be careful if you're, wrapping use effect, that you're handling the dependency array correctly. Same use effect gotchas apply with remembering to memoize or making sure things don't change too often. Yes, you can use effect in here. And all those same caveats of writing normal code using hooks are still the same because that's all a custom hook is just a unit of hook-based code. A concern with this method is that now we lose out on the ability to control any kind of view layer stuff. Right, so we've managed to purely isolate the state-based things, but with our higher order component, as well with our render props, we could do something like in where is our this file has gotten out of hand. Where's toggle render? There it is. Like we could do something like wrapping this inside of a div, like I could div and then style color is blue. And this needs to be JSX. All right, so now we can control some visual aspects of the rendering of this component as well. And this is good because it gives us access to some additional power. But this is also bad in some sense because it lets us do more things. And sometimes preventing us from doing more things is an incredibly valuable tool because we have less mistakes that we can make. However, when you need this kind of stuff, right, there's nothing stopping you from still using render props or using render props in combination with your hook. So that's my little drawbacks and pros diatribe. Does that answer your question?
Absolutely.
Thank you.
I was just thinking I was using a HOC today, where I think I might go back and try and use the custom hook. So.
Yeah. Nice. Yeah. Yeah, and we can see plenty of examples of both, Redux, pre-hooks, all just HOC land. And I think that was a huge impediment for people to be able to learn Redux, is now having to understand this additional concept. Whereas now there's, just like a use selector hook, and it just does more hook things. And I feel like that's much easier for people to digest that, oh, I'm just doing the same thing I always do, except, with this additional caveat this time, instead of like learn about curried higher order components, which is a lot to ask of someone. All right. So that is. Oh yeah.
Sorry. This is a question from a little while ago. Mm-hmm. Kristen does not know that you are not on the Slack channel anymore. She asked,
"Gotcha.
Do higher order components mimic behavior like inheritance in classes?"
They they do in some sense get us similar results. So the big difference between a higher order component and inheritance is a word that I've kept using over and over again without actually explaining, which is composition. Right. So the English idea behind the term composition is that we're able to take these two pieces and make them work together. We've composed them. But composition actually has a mathematical meaning, which essentially means, right, if I have a function, f of x, and I have another function, g of y, I can do something like this, right? I can call my function f of x, and then I can give the result of that to my function g. And I didn't have to use math because we're programmers and we know what functions are, but that's where this term comes from. And the advantage of this, as opposed to inheritance, is that it gives us more options about how we want to handle the way these things compose. A clear example, right, is you can't use a function component for inheritance because that's not how classes work. But also, if we want to compose things multiple times, how do you write a class that inherits from two different things at the same time? Whereas we could call, with toggle, and then we can take the output of that, which was our drop-down component, which is any other component, and we could do something like, with Redux, or I think it's connect is the Redux one, but whatever. Redux drop down or something like that. So we can add more and more layers. There's also just programming issues that people tend to not like about inheritance, with how things like static properties and stuff works, that can be good but also can be bad and confusing. And in general, again, this is a statement largely driven by fashion. Inheritance and object-oriented programming used to be very, very big, industry standard, billions of dollars worth of stuff flows through code written that style. There's nothing wrong with it, but it does have its drawbacks. And I think one, me is trying to teach this coming from the perspective of students who are learning this for the first time, is that when you learn about object-oriented programming and inheritance, I think it gives you a false sense of hierarchy, that programs should be written right like the biological like kingdom phylum tree, and that we should write all these classes that like neatly lock together, and we have vehicle, and car inherits from vehicle, and so does motorcycle and bus, and we end up writing kind of these really weirdly stilted, oddly constructed programs that don't really work too well because you can't see the forest through the trees. So that's why you'll see with React this phrase composition over inheritance. It's very common outside of React, but still in the object-oriented world, to create these kind of wrappers instead of relying on inheritance to combine bits of functionality together. And that is not to say that inheritance is useless, but that's why we don't like it here.
Wonderfully put.
Thank you so much, Henry.
Oh, you're welcome. Any other questions that we got right now? All right. Cool. So that covers our hooks. I guess just to touch on the last thing, I returned an array here. Common convention, if you're returning exactly one or two things, you can use this array syntax or just return the actual value. If you're returning more than two things, you should probably use an object. Because once you have more than two, the amount of mistakes you can make and the order of them grows quite fast. So don't do that. just use an object. All right. So now we have context. So context, if we look at the docs, context isn't the same as our other solutions. What context allows is for us to pass data between components in React through the component hierarchy without doing it linearly via props, where we just keep passing props down. And so it's somewhat a state management solution, but it also helps solve this compositional issue as it comes to sharing this data, as well as it lets us use some interesting patterns to provide like JSX-driven solutions, as well as eliminate the need for render props. But what I'm looking for is the old way to write contexty things. So the old way to write context is you have a context provider, which I've talked about before, but the context consumer, the thing that plucks the value out of context, uses render props. Right? These patterns are kind of inherent to React. And instead of using render props, we can also use hooks, which is very nice, but we still see these patterns everywhere. And they call it function as a child here instead of render props, and I guess that's technically more accurate. But so what we can do with context is we'll just keep expanding this monster file. Is we can create a context, and we'll call it toggle context because we're very creative. And this is react.createContext. Its type is going to be, toggle props or null. Talk about in a previous video, but the default value of our context outside of the provider, we generally want to be null. That way we can know that this is being, whatever is trying to use this context is being rendered outside of it. We can immediately throw some errors. Otherwise, I want it to have the value of our toggle props is open and toggle. We can then create the provider, toggle provider, which is going to be a component that is going to accept children. So I'm going to use our shortcut here, react.function component, and it is going to return those children, which I'm going to destructure real fast out of here. And it's going to be wrapped inside of toggle context dot provider. And it's going to render these children as a child of the actual context provider. And this context provider expects an argument, a prop called value that is going to be the value that we can pluck out of this context and any component that needs it. And instead of writing this logic again, right, instead of grabbing this and copying, pasting, and throwing it up here, I'm just going to use our hook. Right? Nothing can stop me from doing that. I could also use our render props or our HOC or whatever, but I'm just going to say const is open and toggle is equal to use toggle. And this is really nice because, now I've been able to combine these two patterns so we can still use the toggle logic wherever we want it, and now we just additionally have this this context that we can use as well if we want to share the same toggle state between multiple components without having to worry about passing props, which we would have to do with something like render props or lifting our state up, putting our use toggle somewhere higher, which is essentially what we're doing with context, but again, we don't have to worry about props. And this helps us create a better interface if we're writing a library for this kind of thing. So the user doesn't have to worry about doing the prop passing logic for us. So then we need to create a custom hook, right? We could use in the React docs this consumer function as child or render props method, but we can use context with hooks. And context has existed long before hooks. but its popularity has grown greatly in my perception with the introduction of hooks, just because of how easy it makes it. Because I'm going to create a hook called useToggleContext. And what is this? It's just a function that starts with the word lowercase u's. And what we're going to do is we're going to call a hook called useContext. And we're going to give it the value of the toggle context that we created. And that should give us the value, right? Which is this prop here, which is an object that contains isOpen or toggle, right? But if I hover over this, we'll see that its type is actually either toggle props or it's null. And this is one of the wonderful things that TypeScript does for us, is it prevents us from shooting ourselves in the foot here, is we have to remember to handle the case where we're using this hook or rendering a component that uses this hook outside of a context provider. And this is why we've made this default value null, because what I can do is say if value is null, I want to throw a new error that says use toggle context must be used in toggle provider. Now, TypeScript is smart enough to intuit that, well, if the value of this variable value was null, then we throw this error and this function stops running. Therefore, if we've managed to get past this if statement, it must be the object toggle props instead. So now I can go ahead and return that value. And so this is the wonderful custom hook that I use every time that I write a context. You could also create a higher order hook. See, this is why this naming terminology is so bad. But you could create a function that wraps whatever context you want in this. But I'm not going to do that here because we've done enough abstraction. So now we've got this hook. So we could do something like render a toggle provider. And now I could write other components. I'm just going to grab toggle function out of this enormous mess. We'll put it right after this hook. We'll call this toggle function consumer. And our wonderful verbose but accurate names. And instead I will say isOpen and toggle is equal to use toggle context. Now I can delete this. And so what we've gotten ourselves here is a way to not only compose this stateful logic in the way that we would with an HOC, but now we also get freedom in the way that we choose to render this stateful logic like we do with render props. Because now I can wrap this in divs, right, with color blue on it. Or I could do that inside of the consumer. And the user is free to render whatever children they want of this provider and make use of that context in whichever way they so choose. So that's kind of the benefit of context. This also allows us to just make interesting interface choices with our library. So for example, we write this kind of isOpen ternary logic all the time. So we could do something like, and I will do this a bunch sometimes when I'm making certain kinds of components that I want to share, right? I can make a component called like toggle isOpen. And again, this is a bad name, but this will just grab isOpen out of our toggle context. And this will take children, type of React.function component. And if we are open, we can return the children, which I'm going to wrap in a fragment because otherwise TypeScript gets a little ornery about that. Otherwise, it's going to return null. And so now what I can do is I can render toggle is open. We are open. Hey, and there we go. And I could do the same thing with closed. And now we kind of have these cool expressive components that contain their own sets of logic that we can reuse, right? Now we've gotten this interesting bit of rendering logic wrapped up in a component that gets to use this context, and we don't have to worry about render props or making all these things. We're just free to kind of build and extend in fun ways, both as library authors or as just developers of an application where we want to expose enough functionality to the user for them to pick and choose how they use it without making it too complicated. So that is context. Any questions with that? I called this while on. That's a much better name for that component. Yeah. So those are kind of the big ways of sharing this logic inside of just standard React. HOCs, render props, hooks, context kind of building off of the previous options. There's certainly other ways of doing it. I talk about in the notes section of this GitHub repo, right? The reason that it is so difficult to solve this problem is because something like this, something like our toggle function, right? The logic here of transforming is open into its opposite value is deeply tied into this ecosystem where it has access to set is open and the value of is open and things like that. Our logic for transforming state is very tightly coupled to the mechanism that it takes to actually change the state value in our React component, whether that is our hook or whether that is our class-based, this .set state. I can't just take this toggle function out. However, right, most of the time our logic that we use to update this state is out of the patterns that React encourages is pure, right? This function I'm giving to set state, right? We take a previous value of state and we return a new value of state. And there's this function, right? This is where the real magic lives. This is where our actual logic is. This is just a name. This is pure. We could take this out of toggle class and just make it a normal function, and then we can put it back in and we can start to compose state that way. The drawback there is now we have to make sure to maintain the correct representation of state separate from these pure functions. But certainly that's fine and doable, and while writing any application, you're going to write, these pure utility functions over and over again. But what if we were able to combine this, right, and just use this, pure function to represent all of the changes to our state, and then just later, right, bolt on the mechanism both to represent state and both to actually change it within our React component. Hey, and that's the Redux model. That's the reducer model, and that's really where that comes from, is the idea that when we transform state, almost always what we want to do is take a previous value of state and go to a new value. And so the reducer model, the Redux model, is to take that to its logical extreme and just say we have one function that takes in our previous state, takes in the changes that we want to make, gives us the new state. Hooks gives us use reducer to handle actually plugging that in to the React ecosystem. Redux does HOC and context magic before those things were really common in the React ecosystem to be used by not library developers. And so that's kind of the secret option that we can do as well. And certainly there are other solutions out there. I know observables are a thing that I know nothing about that lots of people are excited with, and lots of other state management libraries as well. All right. Whew. It's a lot of talking. I'm going to ask again. Do we got any questions with any of that?
This is somewhat related,
Mm-hmm.
and it has to do with the context pattern. As it concerns scale, you mentioned a couple weeks ago how you can get to a point where you need to split out your context.
Yes.
And there was a reason for that, and I'm trying to remember the explanation of that.
Oh, yeah. And so this is actually a great example that we can do here, which is that this use toggle, right? Which actually I'm gonna not use for a minute. I'm just gonna paste this stuff into here. Right. So the idea is that we have multiple values. Nope. Wrong place. Here we go. We have multiple values that our context is providing, and we provide them all at once as kind of a courtesy, right? Because usually our components care if something is open and how to toggle it, right? Those are coupled together. But we notice some of the components that we render here, right? Like this callback here doesn't actually care about the toggle functionality, and vice versa with some other things that we might want to do. But the problem is, whenever we re-render toggle provider, either because something above it re-rendered and we're just doing the normal React thing, or we call set toggle and the state of isOpen changes, no matter which values you're actually making use of in the context, if anything that our context provide changes, then everything that uses the context is going to change as well. And before we can even get there, we actually have this problem, which the way that React avoids additional renders, right, when we memoize a component, is it just checks and sees if, the props are the same. And we do a similar thing with context, where it will check and see if the value, if that has changed, then we have to re-render everything that relies on this context. So what we want to actually do here is take the use memo hook, and I want to memoize the value of value. So I'm going to say use memo, and if you haven't seen this hook before, what it does is it's similar to useEffect. It takes as its second argument a dependency array, and we say if isOpen or toggle changes, what I want you to do is I want you to recalculate the value that the first argument, this callback function, is returning. And that's just our object isOpen and toggle, and we can give it here. And again, the React linter is very nice. What is it getting mad at me about here? On 60? What? I think the TypeScript compiler is drunk. 65? Oh, it's because I accidentally deleted this from here. Or no, wait, we wanted the consumer. Here we go. Hold on, TypeScript. Hold on. I know I could have just commented this out, but I'm trying not to ruin the value of this source code. Okay, so where were we? We were talking about memoization. And so what this does, right, what memoizing means is that if we know the inputs to a pure function are the same, right, a function that only depends on its inputs to produce its outputs, if the inputs haven't changed, then we know the output hasn't changed, so there's no reason to calculate it again. So one, this avoids the increased computation required to reproduce these results, but two, it makes sure that value has a constant identity as an object unless any of its constituent pieces change. when I just had the object literal here, right, is open and toggle, if we were to ever re-render toggle provider, this is going to be a new object with a new identity, and so React is going to think it has to re-render everything that uses this context. So that's our first step in preventing that performance overhead. Now, should you do this by default? I'd actually argue no. React is fast. It handles re-renders quickly. Most of the time, our components don't actually do that much. The real bottleneck is in the DOM diffing stuff, right? That's big O n cubed. For those of you familiar with big O notation, the algorithm that React uses to like compare and update the changes, that's big O n cubed. So chances are you're not writing things that are going to perform worse than whatever is happening at that level. But eventually things get big enough things depend on your context, maybe your whole application essentially, and then it starts to become a problem. So this use memo is the first step. The second step is splitting context. So what this means, right, is now whenever isOpen or toggle changes, our value changes. We have to re-render everything. But toggle actually doesn't change. I'm going to make use of another hook here called useCallback. And useCallback, it's the exact same thing as useMemo, but it just accepts the fact that the callback function we're giving it is the thing that I want to memoize instead of having to give it a callback function that returns a callback function. So what we do is we wrap the value of toggle in useCallback, and we can give this an empty dependency array. And normally the linter would complain to us about the fact that setIsOpen could change, so we would have to change the function toggle here whenever setIsOpen changes, but React knows that setIsOpen is from this useState hook, and in fact this function will never change. When you call this hook for the first time, you get the setIsOpen function, and you get the same function every time you re-render. So toggle never has to change. If we did this, right, now the React linter is going to yell at us because, one, we should be using the callback thing, but two, now technically this function needs to be recalculated every time the value of isOpen changes, because it needs the new value in its closure. So that's one of the other advantages of using this callback method. But now toggle is a constant value. When we first provide our toggle context, we calculate the toggle function, it never changes. So if a component only needs this toggle function, then it should be able to get that and not have to re-render whenever isOpen changes. So this could be important. For example, let's say you have let's make up a situation that hasn't happened to any of us in specific before. Let's say you have a context that represents the cart on your e-commerce site, and you have a value that is the items in the cart, and you also have a function that adds an item to the cart. Now, you can have many, like product cards on a page that all have a button to add that item to a cart. But if the cart value and the cart add function are both in the same context, whenever you add a value to the cart, the context is going to change, and you're going to end up re-rendering all of those cards, even though they don't actually care what's in the cart. They just need the ability to add things to it. And so what we can do is we can split the context. We could do something like toggle provider. This is where my naming is really starting to get poor. But we could call this like toggle, function provider, and it could have a value that is just the function toggle, right? And we can just wrap our children up in both of these. We don't have to create more than one toggle provider, our nice wrapper component. Instead, we just split the context, and then we have additional use our context custom hooks. So we would have use toggle value and use toggle function or something like that. And so that's splitting the context. So now this toggle function provider is actually never going to re-render, right? If something calls use toggle, it's going to get that value first time, and that's never going to change. So we can flip the value of toggle as much as we want and not worry about that changing anything that relies only on this context. You might be thinking to yourself, well, that's kind of weird and cumbersome and odd. Who would actually use this pattern? Well, React Router has been my choice of late for examples because I think it captures a lot of these patterns really well. But you'll notice the HOCs API, you have use history, use location, use params, use route match. You have these 4 different hooks. And I remember when I started using this, I was like, why can't I get something that gives me both the params and the history in one hook? Why do I have to keep using more than one hook? It's very annoying to me. And the reason is exactly because of this splitting of context. The history object changes at different points in time when compared to the use params object. And we don't want essentially our entire application that depends on some facet of React Router to re-render whenever any of these change, right? We want to drill down and be more specific. So that is why and how we split context.
Beautiful.
Oh, thank you. Thank you. Any questions anyone has there about that or memoization? I know I kind of breezed by that if you're new to that concept. All right. Cool. Well, was there anything else that we wanted to take a look at today with this or anything else?
Off the books if you're going to stick around.
Yeah. I will stick around for a minute after I end the recording. I'm just going to sneak in one extra thing, which again, we're going to take a look at the React Router source. The React Router route component, let's actually get both of these up. These days we can use children just fine because the hooks and context API works great, and that's how we prefer to compose that logic. But route actually accepts multiple arguments here for how we want to do the kind of prop composing based rendering. We have children, which good for context or things that don't actually care about any of the React Router state. But we also have a render prop, right, which we know and love. We learned about render props. We also have a component prop, which is like a render prop, except it expects a component, which you could write a function in here, right? There's no real difference in between the type of a render prop function and a React component function. But the important difference here is how React Router handles these things. And let's go and find route. And that is in the way that we call them. So when we have a render prop, right, we call it the same way that we did. It's a function. It accepts arguments, and then we take back the results it has. When we have a component, we use this react.createElement function. And this may be shocking to you who have never seen this before. And there's not a lot of good reasons for you to see it, unless you're doing some pretty funky stuff. But this is what React actually does. You don't need JSX to write React, because when I write something like, I don't know, drop down, what I'm actually doing is I'm calling react.createElement drop down. And if I wanted to give this props, I could. And I would say, is open to be true. And that's all JSX is doing, is it is putting a wrapper around React.create element for us that looks more like HTML. But the advantage here is that that's how React does its magic to know things like, you know, key identity and unmounting, remounting, to be able to do hook stuff, to be able to do memoization. That's all tied up in React.create element, which if we give that a function that is going to change on every render is going to kind of gum up the React works. So we don't want to do that. So the component prop is another pattern that I didn't bring up, very similar to the render prop, but largely outmoded by our ability to do context things these days. Okay, so that was the last thing that I wanted to talk about. So I'm going to go ahead and end the recording here and then stick around for a minute to chat about other stuff. So thank you, all of those watching on other platforms, and I'll see you later.